Hello, my name is Jennifer Patbeck, and I would like to welcome you to our Analytical Talks. In this episode, we are going to talk about water analysis. Let's start by taking a closer look which topics we are going to discuss today. First off, I would like to give a brief overview of Hamamatsu as a company. Then, we will have a closer look at why monitoring water quality is important to us and our environment. This presentation is chaptered in two. For water analysis important special regions, the UV and the VIS region. We will start with the UV and see some applications and which products from HAMAMATSU Photonics are suitable. I will continue with the VIS region. As before, we will look deeper into applications for the VIS photometry and learn more about products best suited for this wavelength region. I will finish this webinar with a short summary and how to contact me or one of my colleagues if you might have open questions or need more information on a product. Let's start with a brief overview of the Hamamatsu world. Hamamatsu Photonics has been established in 1953 and is located in Hamamatsu, which is approximately 300 kilometers south of Tokyo. In total, Hamamatsu Photonics has 10 department bases. 3 of them are only devoted to research and the development of new technologies. To keep being a pioneer in new technologies, Hamamatsu Photonics spends 9% on R&D departments. With over 5,000 employees working all over the world, Hamamatsu Photonics is a steadily growing international company. Especially proud makes us that some products have contributed to 3 Nobel Prizes. 2 Nobel Prizes have been awarded at the Kamiokande, respectively Super Kamiokande experiment for the observation of neutrinos and neutrino oscillation. Our 20-inch PMT, which is the world's largest, could capture this phenomenon. 1 Nobel Prize was awarded in 2013 for the discovery of the Higgs boson at the Large Hadron Collider, which is one of 7 stationary experiments at CERN. Our silicon strip detectors are implemented in the detector system. As a last point, Hamamatsu Photonics had over 15,000 products in the standard portfolio. In the following slide, I would like to give you a short overview. Hamamatsu offers different kinds of light and radiation sources, for example LED, lamps, but also lamps modules, which already include the electronics. We also offer optical components, like fiber optic plates, flow cells, and SIR substrates, which stands for Surface Enhanced Raman Spectroscopy. The portfolio also includes lasers, like continuous wavelength lasers, but also pulsed laser diodes. Complete cameras are also part of our product portfolio. Biggest portfolio can be found in optical sensors, which include, for example, photodiodes, ranging from the UV to the IR, PMTs, large sensors, image sensors, spectrometers, infrared detectors, and X-ray sensors, just to name some of the typical sensors. But we also offer complete systems, like drug screening systems and a pinhole inspection unit. We will come back to some of the mentioned products during the application section of this webinar. After this short introduction to the Hamamatsu world, let's have a look at why it is important to monitor water quality. When we turn on the tap and fill up a glass or go for a dip in the ocean, most of us take it for granted that these are all safe actions. The reality is that behind the scenes, scientists work tirelessly to ensure that the quality of the world's most valuable resource is as high as possible. So why is monitoring the quality of water so important? With the UNESCO World Water Assignment Program, reporting that every day 2 million tons of human waste is deposited into watercourses, keeping tabs on quality is critical. At its core, the practice serves 5 major purposes. First off, the quality of drinking water is crucial. Human health depends on clean water supplies. Then, of course, we have to monitor water quality regularly to identify any existing problem. For example, data has been used to reveal that over the past 4 years, increases in fertilizers used for food production had increased global nitrogen pollution in rivers by up to 20%. We also need to monitor water reuse. In many countries, drinking water is a valued good, therefore it is crucial to reprocess water. We also need to check whether pollution regulations are being complied with. Then, of course, we need to think of our future. Collecting data could bring new insight and strategies for pollution prevention. As one can see, in these 5 points, monitoring water quality is essential to keep the planet healthy and sustainable. In the next slides, we will learn how HAMAMATSU Photonics technologies can help achieving with this goal. As mentioned before, this presentation is chaptered in the applications and suitable products, photometry in the UV and in the VIS. Let's start with the UV section. As mentioned in the short introduction, nitrogen pollution in rivers, lakes and other water bodies is a growing issue. Fertilizers used in agriculture can sweep down to watercourses and cause excessive growth of algae. This may lead to low levels of dissolved oxygen and can cause even death zones. Total nitrogen is the sum of inorganic nitrogen, organic and ammonia. It can be measured in the UV at 220 nanometers, and HAMAMATSU Photonics offers a special high-sensitivity photodiode at this wavelength. The S12742 uses an interface filter for its window and is sensitive only to monochromatic light. The spectral response width is extremely narrow at 10 nanometers, which allows accurate photometry without any effects of stray light. Another crucial value for the health of an aquatic ecosystem is the amount of dissolved organic carbon, or the amount of organic matter, short for DOM. So why is this value important for a sustainable water body? The larger the carbon or organic content, the more oxygen is consumed. A high organic content means increases in the growth of microorganisms, which contribute to the depletion of oxygen. The source of this organic material could be a wastewater treatment plant, releasing wastewater into a stream. And how can we measure organic carbon? The UV254, or sometimes referred to as SAC, short for spectral absorption coefficient, is an optical technology which utilizes UV light at 254 nanometers and is able to detect organic matter in water. Typically, this measurement is presented as a calculation of UV absorbance and transmittance. Especially for the UV254 method, HAMAMATSU also offers a photodiode with a filter and center sensitivity wavelength at 254 nanometers. But even for other applications, this photodiode can be customized to serve other peak sensitivities. If we want to look at a broader spectrum in the UV, HAMAMATSU offers also high UV sensitivity and high UV resistance photodiodes. Here we find the high UV sensitivity silicon photodiodes, either a standard type or with suppressed IR sensitivity. Both photodiodes are best suitable for low-level light detection and can be customized in package and window material. There's even the possibility to form customized filters on the window. Here we find the high UV-resistant silicon photodiode that have achieved high reliability for monitoring UV light. They exhibit low sensitivity deterioration under UV light and have a special UV glass window, which is hermetically sealed, making it best suited for wet environments. Furthermore, no resin has been used, which could cause outgassing. In the diagram, one can see improvements to the conventional type, which has been measured after 1000 hours permanent radiation with a deuterium lamp. Next, I would like to show you our back-illuminated silicon photodiode, which combines high UV sensitivity and high UV resistance. It exhibits low sensitivity deterioration under UV light and has a quantum efficiency of 75% and 200 nanometers. It is designed with minimal dead space around the product and comes in a chip-sized package. This makes it possible to arrange multiple diodes side by side. I also want to introduce our UV sensitivity MPPC. This stands for multi-pixel photon counters. MPPCs are also known as silicon photomultipliers and are made of high-density matrix of Geiger mode-operated avalanche photodiodes, known as SPAT, which stands for Single Photon Avalanche Photodiode. These SPATs have high internal gain, which enables single photon detection. HAMAMATSU's MPPCs feature low dark count, high photon detection efficiency, excellent timing resolution, and are immune to magnetic fields. Finishing now from the detection side, we focus in the next couple of slides on suitable light sources in the UV. I would like to start with xenon flash lamps and modules. As most will know, xenon flash lamps are pulsed light sources that emit with an instantaneously high peak output. The emitted light is a continuous spectrum ranging from the UV to the infrared region and is used in a broad range of applications. Hamamatsu provides high-quality and high-precision lamps designed and manufactured entirely in-house. On the picture, you can find 3 of our xenon flash lamps modules. These modules integrate a 2-watt xenon flash lamp with power supply and trigger socket. The version of the far right is designed on a cylindrical circuit board, offering high degree of design freedom. This module can operate on a 5-watt battery and allow assembly into portable analytic instruments. The lifetime is given in flashes, but these modules are also suitable for permanent operation. In the following, I want to concentrate on 4 main features. First feature is the high efficiency of xenon flash lamps. Compared to halogen lamps, xenon flash lamps emit high sensitivity light that is instantaneously 1,000 times greater. Then second, the low heat generation. Xenon flash lamps generate low heat, so warm-up time is reduced. We can see in the image that we have approximately output stability after 40 seconds. Third would be the high stability. The unique electrode design provides a highly stable discharge with less electron wear. The peak-to-peak stability is less than 1%. And last, the long lifetime. As mentioned in my last point, the electron design ensures minimum electron wear and allows maintaining high performance over long-term operation. The red line shows life characteristics of the whole spectrum and is given in numbers of flashes. It even reaches 80% after approximately 8 times 10 to the 8 flashes. But since it is not completely avoidable that pulsed light sources bring small variations, deuterium lamps are best suited when it comes to ultra-high stability applications. As before, I would like to concentrate on 4 main features: the long lifetime, the high stability of the ceramic electrode, as well as the cathode, and as a last feature, the lighting performance. Prior lamps used quartz glass, which had some negative effects on the lifetime. The UV light caused deterioration in transmittance, and the quartz glass showed blurring after some time. We solved this problem by exchanging quartz glass with UV transmitting glass. This UV transmitting glass has high UV resistance, is of high quality, and no generation of ozone occurred. With this adjustment, we can assure a lifetime of 2,000 hours operation. Also, other improvements have been done, which led to high stability. The material of the electrode has been changed from a metal to a specially designed ceramic electrode. This led to excellent temperature characteristics, which ensures high stability. But also the electrode spacing variations could be minimized, which had positive effects on stability. The characteristic of the cathode could be also improved by switching to a super-quiet cathode. By doing so, the fluctuations of the electron emission could be minimized. All these improvements can be summarized in the light output stability curve above. Even after 2,000 hours of operation, high stability can be maintained. As a last feature, I would like to look deeper into the lighting performance. The auxiliary lighting method is an improvement of the conventional lighting method and ensures ignition even under hot condition or at the end of the lifetime. Here, an additional capacitor functions as an ignition aid. One can find a drawing of a typical structure of a deuterium lamp with the anode, the electrode, the cathode, the bulb, and the light output is only in one direction. With this, I would like to end the UV section and come to the photometry in the VIS region. First, let me start with the measurement of phytoplankton as an application. The attendance of phytoplankton is crucial in a healthy ecosystem. since it absorbs nutrients from the water to grow and removes ammonia and nitrogen, which is particularly important since it can be toxic in higher concentrations. But it also supports the ecosystem by absorbing CO2 and purifies the water. In that way, phytoplankton can reduce the pollution caused by domestic, industrial and agricultural wastewater. A very established way to measure the amount and type of phytoplankton is by absorbance and fluorescent measurement of chlorophyll. This method can be also used to measure the ratio of blue and green algae and the appearance of a red tide. HAMAMATSU Photonics offers several suitable photon detectors like MPPCs, sensitive, indivisible, and our MOMs spectrometers. I will come back to our menu spectrometers in the next slide. As a last application, we have a closer look into turbidity and color analysis of water, which is the study of optical properties that cause light through water to be scattered and absorbed rather than transmitted in straight lines. Turbidity causes cloudiness or a decrease in transparency of water. The direction of the transmitted light path will undergo changes when the light hits the particles in the water column. If the turbidity level is low, less light will be scattered away from its original direction. Light scattered by particles such as silt, clay, algae, organic matter, and organisms may enable the direction of these particles in water. As shortly mentioned before, our fingertip-size spectrometer is a high sensitivity, yet ultra-compact solution that supports a spectral response range from 340 to 850 nanometers. Therefore, suits the specifications needed for turbidity and color analysis. It is hermetically sealed, which provides humidity resistance and is very robust against shock and vibration. Even as a low-cost solution, it can provide spectral resolution of less than 10 nanometer typically. As a last product, I would like to also introduce our rather new silicon photodiodes, which have a broad spectrum, from the VIS to the near-infrared range. The S12915 is a successor product to the S2387, and the improvements in the sensitivity can be seen on the right graph. As one can see, these diodes reach almost a 100% quantum efficiency over a broad spectrum. They are especially designed to be used in high humidity environments and have low dark current and high linearity. They also come in different photosensitive sizes, but there is also the possibility for customization. And this brings me almost to the end of my webinar. But let me summarize what products we saw today. First, we saw that HAMAMATSU offers high sensitivity and high resistance photodiodes for the UV, but also for the visible and the near-infrared range. We also offer MPPCs or silicon photomultipliers for photon counting applications. Also here, we offer suitable products for UV and VIS. HAMAMATSU has a new UV spectrometer for gathering the whole information in the UV. We learned about high-performance xenon flash lamps for process analysis. For high accuracy application, HAMAMATSU offers very stable and powerful deuterium lamps. But if you have a special request, there's always the possibility for customization. If that is the case, please ask for assistance and contact us. And with this, I would like to thank you for your attention. If you have open questions or you would like to ask for more information of one application or of one of our products, you can either contact me or my colleague, Mr. Kunert. Thank you again and goodbye.